All right, so to get this, we're diving deep into the moon today,
Oh, cool.
but not in the way you might think.
Okay.
We're talking about a lunar facelift.
Ah.
And I'm not talking about some new crater or anything.
Yeah.
Some of the moon's rocks seem way younger than others,
Oh, interesting.
and scientists are trying to figure out why.
I see.
It's kind of like imagine finding an old photo album,
Okay.
but some of the pictures look brand new.
Yeah.
That's the mystery we're tackling today.
That's wild. Well, it's a fascinating puzzle for sure.
Yeah.
And it all starts with the moon's origin story.
Okay.
The most popular theory is the giant impact theory.
Right.
So picture this with the early Earth
Okay.
colliding with a Mars-sized object called Theia, and the debris from that cosmic crash eventually clumped together to form our moon.
Okay, giant impact. Got it.
Yeah.
But how does that explain the age discrepancy in the moon's rocks?
Right.
Some samples, like those brought back from the Apollo missions, date back 4.35 billion years. But then we have these zircon grains that are way older, clocking in at 4.51 billion years.
Exactly. And that's where this whole lunar facelift idea comes in.
Okay.
A study published in Nature suggests that about 200 million years after the moon formed, something caused a second melting event. Essentially resetting the age of some of the lunar surface.
A second melting. Okay, that's wild. But what could possibly cause an entire celestial body to melt twice?
Well, the prime suspect is actually closer to home than you might think.
Really?
It all comes down to Earth's gravity.
Okay.
And the moon's orbit billions of years ago. You see, the moon wasn't always as far away as it is today.
Right.
Early on, it was much closer to Earth, maybe only about 20,000 miles away.
Hold on, 20,000 miles. That's like a tenth of the distance it is now.
Yeah.
I bet that made for some seriously intense tides.
You're absolutely right.
Wow.
At that distance, Earth's gravitational pull would have been incredibly strong.
Yeah.
Stretching and squeezing the moon. Oh.
Generating a ton of heat inside. It's like constantly squeezing a stress ball. It heats up.
Okay, I'm starting to see how Earth's gravity could have been the culprit behind this second lunar meltdown.
Yeah.
But wait, wasn't there also something about a special zone the moon passed through?
You're thinking of the Laplace plane transition.
Laplace plane transition.
It's this region where the gravitational pull from both Earth and the sun would have been perfectly aligned.
Wow.
Amplifying the tidal forces on the moon.
Oh.
Imagine the moon passing through this cosmic sweet spot.
Yeah.
Getting a super intense gravitational squeeze from both Earth and the sun.
So it wasn't just Earth's gravity, but a sort of tag team effort with the sun making the tidal forces even more extreme.
Exactly.
But here's what's bugging me. If this second melting happened so long ago, wouldn't Earth have needed oceans to create those massive tides?
That's a great point.
Yeah.
Today, it's the bulging of Earth's oceans caused by the moon's gravity.
That creates the tides we experience.
Right.
But here's the catch. Earth's oceans didn't exist 4.35 billion years ago.
What?
They formed much later.
So no oceans, no tides, no lunar facelift. That doesn't add up.
Right.
How did the moon even get pushed out to that special zone if there were no oceans to drive the tides?
Well, the researchers who proposed this lunar facelift idea have a clever solution.
Okay.
Picture the early Earth.
Okay.
Molten, lumpy.
Yeah.
And spinning incredibly fast.
Oh, wow.
We're talking days that were only 4 hours long.
4-hour days. That's some serious spin cycle action.
I know, right?
But how does that explain the moon's outward drift?
Well, that rapid rotation, combined with Earth's molten bulges, would have acted like tides, providing enough gravitational push to move the moon outward, even without oceans.
So basically, the early Earth was such a wild child, its spin was enough to mimic the effects of ocean tides.
Precisely. It's amazing to think that even without oceans, Earth's spin was powerful enough to reshape the moon.
That's incredible. So this whole lunar facelift idea has some pretty significant implications for some of the moon's most famous features.
Absolutely.
I'm all ears. When you said lunar facelift earlier, I immediately thought of craters, but I bet you're talking about something much bigger.
You got it.
Okay.
Think about those massive dark patches you see on the moon. Those are called basins.
Basins.
And they're basically gigantic impact craters.
Wow.
Left over from collisions with asteroids or comets.
I see.
Two of the most famous are the Procellarum Basin.
Procellarum Basin.
Which forms the man in the moon's right eye.
Oh, right.
And the South Pole Aitken Basin.
South Pole Aitken Basin.
Which is on the far side of the moon.
Okay, I was fascinated by those basins. They're like scars that tell the story of the moon's violent past.
Exactly.
Yeah.
And here's where the timing of this lunar facelift gets really interesting. If this second melting event happened around 4.35 billion years ago, as the study suggests, it sets a critical minimum age for those basins.
Wait, are you saying those basins couldn't have formed before the moon's second melting?
Think of it this way. If those giant impacts had happened earlier, any trace of them would have been completely wiped out by the intense volcanic activity that accompanied the second melting.
I see.
It's like repaving a road.
Okay.
Any potholes or cracks that were there before get completely covered up.
So these basins are like time capsules telling us what happened after the moon got its dramatic resurfacing. That's so cool. It's like using geological formations on Earth to piece together our planet's history, but on a lunar scale.
That's a great analogy. It shows how interconnected everything is. We're learning about the moon's history, but it also tells us about the forces that shaped our solar system, and maybe even other solar systems out there.
Okay, so we've got this moon that's closer to Earth than it is today, getting squeezed and heated by Earth's gravity, and then bam, a second melting.
Right.
And this tells us that these huge basins formed after that.
Exactly.
But what about other places in the solar system? Could they have gotten a similar makeover?
That's a great question, and it's something scientists are actively investigating.
Cool.
If tidal forces were so powerful in the early solar system, it stands to reason that other planets and moons might bear the marks of similar events.
I'm thinking about Jupiter's moon, Io.
Yes.
It's the most volcanically active world in our solar system.
It is.
Are those erupting volcanoes we see a result of tidal heating too?
You bet.
Wow.
Io is caught in a gravitational tug-of-war between Jupiter and some of its other moons.
Okay.
That constant stretching and squeezing generates a tremendous amount of internal heat, leading to those spectacular volcanic eruptions.
It's mind-blowing to think that gravity, a force we usually associate with stability, can also be a powerful agent of change, sculpting landscapes, and even driving volcanic activity across vast distances.
It really challenges our assumptions about how planets and moons evolve. Take Saturn's moon Enceladus, for example. It has these geysers erupting from its south polar region, spewing water vapor and ice particles into space.
And you say?
And guess what?
What?
Tidal forces are thought to be the key to keeping Enceladus's internal ocean liquid, allowing those plumes to erupt.
So these aren't just isolated events. It seems like tidal forces have played a crucial role in shaping the landscapes and even the potential habitability of worlds across our solar system.
Exactly.
But what about our own planet? Did Earth get its own facelift from this gravitational dance with the moon?
Well, Earth doesn't show signs of a dramatic resurfacing event like the moon. The tidal interactions between the two bodies have undoubtedly had a significant impact on our planet's history.
Like what?
For example, the moon helps to stabilize Earth's axial tilt.
Okay.
Which is what gives us our regular seasons.
You're saying that without the moon, lunar tilt could have been much more chaotic, making it much harder for life to evolve as we know it.
That's one possibility.
Wow.
The moon's gravitational influence has helped to create a relatively stable environment on Earth. A key factor in the emergence and evolution of life as we know it.
It makes you realize that even seemingly distant cosmic events can have ripple effects that extend across billions of years, ultimately influencing the course of life on our own planet. That's incredible. But I'm curious, what does this all mean for our understanding of the moon itself? Is it just a time capsule of the early solar system, or is there more to the story?
It's definitely more than just a time capsule.
Okay.
It's an active world with a fascinating and complex history that we're only beginning to understand.
So this whole lunar facelift thing is more than just a cool name. It's a reminder that the moon is a dynamic world, still evolving and changing in ways we're just starting to unravel.
Exactly. It really is remarkable how much we're still learning about the moon. You know, this whole lunar facelift idea. It highlights just how dynamic and interconnected our solar system is.
Hourly.
It makes you wonder what other secrets are waiting to be discovered out there.
I know. We started off talking about how some of the moon's rocks seem younger than others, and now we're talking about the moon's role in the evolution of life on Earth. It's like peeling back layers of a cosmic onion, and each layer reveals something even more intriguing.
That's a great way to put it. It's all about connecting the dots, seeing how seemingly unrelated phenomena are actually intertwined. This lunar facelift, for example. It tells us about the early solar system's chaotic environment. the intense gravitational forces that were at play, and how those forces shaped not just the moon's surface, but potentially Earth's habitability as well.
It's a reminder that we're not just studying rocks and craters. We're studying processes that have shaped the very conditions for life as we know it.
Exactly. And the more we explore, the more we realize how much we still don't know.
Right.
Take those basins we were talking about.
Okay.
The Procellarum and South Pole Aitken basins.
Yeah.
They're like giant windows into the moon's interior.
Oh, wow.
And they might hold clues to the composition of the moon's mantle.
Interesting.
Which could tell us even more about how the moon formed and evolved.
So even though we've been studying the moon for centuries and even sent astronauts there, it still holds so many mysteries.
Absolutely, and that's what makes it so exciting. Every new discovery, every new piece of data brings us closer to understanding our place in the universe.
It makes you realize that science is not about having all the answers. It's about asking the right questions, being open to new possibilities, and embracing the mystery and wonder of the cosmos.
Couldn't have said it better myself.
Oh.
This whole deep dive into the lunar facelift has been a fantastic example of that. We started with a simple observation, some rocks are younger than others, and ended up exploring the formation of the moon, the evolution of Earth, and the incredible power of tidal forces.
So to wrap things up for you listening, it's clear that the moon is far from a static, unchanging object.
Right.
It's a dynamic world with a rich history, shaped by powerful forces that have resonated across billions of years. And the more we learn about it, the more we learn about ourselves, our planet, and our place in this vast, ever-evolving universe.
Beautifully put. And perhaps the most important lesson we can take away from this is that the universe is full of surprises. So keep looking up, keep asking questions, and never stop exploring.
And who knows, maybe someday you'll be the one to uncover the next lunar facelift.
Yeah.
Rewriting the textbooks and changing our understanding of the cosmos forever.
It really makes you think, how much we still don't know about the moon.
I know, right?
It's crazy. Like this whole lunar facelift really shows how dynamic and interconnected the solar system is. Makes you wonder what else is out there just waiting to be found.
Totally. We started talking about some moon rocks looking younger than others.
Right.
And now we're talking about how the moon might have helped life evolve on Earth.
It is pretty wild.
It's like every time we learn something new,
Uh-huh.
it opens up a whole bunch of new questions.
I know what you mean. It's like we're connecting the dots.
Yeah.
Seeing how things we thought were totally separate actually fit together.
It's kind of like a puzzle, isn't it?
It is. Like this lunar facelift idea tells us about the early solar system.
Okay.
All chaotic and full of intense gravity.
Yeah.
And how that shaped the moon.
Uh-huh.
But maybe even Earth, too.
Yeah. And whether life could even get started here.
Exactly.
Yeah.
We're not just studying rocks and craters, you know?
I know, right? It's so much bigger than that.
We're studying the processes that made life possible.
It's pretty mind-blowing when you think about it.
It really is. And the more we learn, the more we realize we don't know.
Yeah, that's true. Like those basins we talked about.
The Procellarum and South Pole Aitken.
Yeah, those ones. It's like they're giant windows.
Into the moon's insides.
Right. And they might hold clues about the moon's mantle.
Exactly. Which could tell us so much about how the moon formed and changed over time.
It's amazing to think we've studied the moon for so long.
I know, right?
Sent people there even.
Uh-huh.
And there's still so many mysteries.
Oh, absolutely. That's what keeps it exciting.
For sure. Each new thing we discover.
Every new piece of data.
It brings us closer to understanding our place in the universe.
I love that. It's like science isn't about knowing all the answers.
Yeah.
It's about asking the right questions.
Totally. Being open to new ideas.
And just being awestruck by the cosmos.
Couldn't have said it better myself.
This deep dive into the lunar facelift has been a perfect example of that, wouldn't you say?
Totally. We started with something simple.
Some moon rocks looking younger.
Yeah, and we ended up talking about the moon forming.
Earth evolving.
And the power of gravity.
It's amazing.
So to wrap things up for our listeners, it's clear that the moon is far from boring.
Oh, definitely not.
It's constantly changing and evolving, shaped by these massive forces over billions of years.
And the more we learn about it.
The more we learn about ourselves and Earth.
And where we fit into this crazy universe.
Beautifully said. And the coolest part is...
What's that?
The universe is full of surprises.
It really is. So keep looking up.
Yeah. Keep asking questions.
And never stop exploring.
And who knows, maybe you listening will be the one to make the next big discovery about the moon.
Maybe you'll find another lunar facelift.
Right. And change how we see the universe forever.